How's it going, everybody? Welcome back. So today I was going to take a look at a game called TIS-100 from Zachtronics, one of my favorite indie developers, well, solo developers, I guess I should say. So Zach's games are super nerdy. I don't want to be insulting because I think they're amazing, but they're always something strange. The first game of his that I really liked was a game called Space Chem, and basically you built molecules using the same sort of mechanics you would use to build a continuous process machine in like a factory or something. So it's kind of this assembly line thing. Infinifactory, another game by the same guy, does the same thing, right? And there are always these weird sort of esoteric concepts kind of built around programming. So the latest one is one called TIS-100. And TIS stands for Tessellated Intelligence System. And let me read to you from the manual. And it has a manual. I wish I had the stream set up so I could show you, but the manual is literally like page by page, just like a computer from the 70s or the 80s. It's amazing. So the Tessellated Intelligence System is a massively parallel computer architecture comprised of non-uniformly interconnected heterogeneous nodes. The Tessellated Intelligence System is ideal for applications requiring complex data stream processing, such as automated financial trading, bulk data collection, and civilian behavioral analysis. So note that last part. Another interesting element of Zach's games, the ones that I've played at least, is that they always tell these sort of weird fiction stories. And so note that last one, civilian behavioral analysis, and note the name of the system, the Tessellated Intelligence System. I wonder what that's all about. Alright, so right underneath that it says note. Notes like this one will appear. Sorry, that's a note on the manual. Alright, so the TIS is basically a programmable microcomputer, except that it's massively parallelized along nodes, kind of like the PlayStation 2 architecture. So each of these boxes here is a node in the TIS, and there's something wrong with them, and I have to debug them and figure out what to get the whole computer to operate the way it's supposed to. So to run the diagnostics, you go to a particular node, and you create a new program, and the program, as you can see from this command here, is written in assembler code. This is the cool part of the game. So there really is sort of functional programming going on, right? So these are nodes, and in them are the instructions that they execute. Data comes in from one of the edges of the node and can go out from one of the edges as well. Remember, it's parallel. So it also has this thing called the accumulator, which is basically a memory register. You can store the value that you're modifying using the code. You can also back it up in this backup. And then these are some diagnostic information about the cell. What number it worked with last, what mode it's currently in, the percentage of its time it spends idle. Now, for the diagnostic to complete successfully, I need to read a value from in X, that's this piece right here, and write the value to out X. Then I need to read a value from in A and write the value to out A. So in A is over here, in X is here. So if you look, in X is basically already set up so that you can take a value from in X into this node, and it'll move whatever it receives from the upper edge down, excuse me, into this node, which also moves anything it receives from the upper edge down. Then this node does the exact same thing, takes the number from above and passes it down, which is out X. So this makes in X output its value to out X, just like we need to do here. So that means that if you give it the number 51, it'll output the number 51. Now A is a little trickier, and you'll note there's no code here. Here's the actual puzzle of this level. A is a little trickier because there's something wrong with this block here. So this piece of it's not working, this node. And if you click on it, you'll find out that what's happened is somebody's used it to store data permanently. It says, can't find a pen right now, so I'm just going to take notes here. It looks like short-term storage. Turns out it was wrong, because this thing was found in a swap meet years later. That's how you get a hold of it, according to the manual. And this stuff was still on it after you powered it up. Randy is the guy that you are in the story, I think, or the guy that you're following. Maybe you inherit the computer from Randy somehow. I haven't actually unlocked the rest of the story, so I'm not sure. But he says, got this one at a swap meet today. Fellow wanted 450 for it, but I talked him down to 200. Good deal. No idea who makes this thing. Never heard of this series. Or never heard of the TIS series, and the architecture doesn't look like anything I've seen before. Ask the guys down at, and then there's some corruption, but no joy. Randy has a mystery on his hands. So even the guy that you got the computer from, if you're not him, has no idea what's going on here. But because he put that note there, I now have to move the data around that node to come out. And so I'm going to do that right now. We're going to move up left. So that'll take the data from in A and it'll move it one step to the left. So that means that this needs to take anything that comes in from the right and move it down. Now you notice to write it properly there really ought to be a comma here, but Zach's been good enough that I can actually not do that, which is nice because I often forget. It's just bad programming. Alright, so once I move that down, then I need to take it from here, and I need to move it down to this node here. Once I get something here, I need to move it to the right. And anything that comes in from the left, I need to move down. And ta-da, output A. So now I can run the code. And if I want to, I can step through it command by command so that you can see, alright, it's getting ready to run its test. Coming in from A here is 51 from up at the top. In X, I mean. And then coming in from A is 68. So, let's see. Now you see that 51 moved from there down, just like it executed. And this one moved from here left, just like we coded it to. So in the next step, 51 gets shuttled down, 68 gets shuttled down. In the next step, 68 is now down here, 51 is out. So you'll see we've now passed the test on that instruction. 68, by the way, is now moved over to the left edge here, and out. And so now 68. So once you're pretty sure it works, you can fast forward it, and it'll just run all the way through the end. At the end, you get a diagnostic that tells you how well it did. So 83 cycles, 83 ticks is the shortest. You can see this is from everybody playing the game, right? And these names are people I know. So Snipehunter is me, Scatarius is a friend of mine. Right, and so these are our scores, and you'll see that we all have them the same, whether it's number of nodes that you used or the number of instructions you actually wrote. And that's because being the tutorial, there really isn't anything else you can do. However, as we move into other nodes, things get a lot more complicated. So now you can see this whole pattern is now clear, and I can do all kinds of cool stuff if I know what to do. But these two blocks are blocked. And in this one it says, continues to baffle. And this is from 1979. Continues to baffle. Chatted with Bernie at IBM, and he says it sounds like something they'd come up with in the USSR. But then why is the manual in English? It's a good question, and the manual totally is in English. Alright, so for this diagnostic, I need to read a value from input A, double the value, and then write the value to output A. Okay. So, I can say, move up what I get from the upper edge into the ACC register, the accumulator, which remember is this little variable here. Now to double it, I need to add it to itself. So I think I can type add ACC. Add is a command that just automatically adds whatever value you give it to the accumulator. Okay, now that I have my value doubled, I just need to shuttle it around, right? So we can go move ACC down. This can say move ACC down. Oops, I don't want ACC because this is now coming from the upper edge. My mistake. Alright, then I can say move what I get up to the right, then move what I get from the left down. And so it seems like that'll work, right? That's a pretty simple program. So let's see what happens. Alright, so 66 is coming in from up. I'm going to move it to the accumulator. Now I'm going to add the accumulator back. See, got my doubled value. I move my accumulator down. Note my idle percentage. So that means this thing's been waiting here for me to do stuff for 25% of the cycles that have been along. That's not maybe very efficient. Alright, so 132 is now down here. So far so good. 132 is now here, exactly as planned. And 132 is out. So this absolutely will work. So let's let it run. It's really slow. Like, really slow. Now, I can tell by looking at it, and you can actually see from my previous attempts that I did much better, but I can tell from looking at it that I found the most popular solution. Look how many cycles it is, and look, there's a bunch of people who figured out how to do it better. Looks like everybody used 4 nodes for their smallest, and that's probably this run through. I should probably point out too that these 3 things can be different. So this 84, 4, and 6 wasn't from one program. They were actually from multiple different attempts to debug the node. So just because I got 84 cycles doesn't necessarily mean that I used 4 nodes to do it, or that I used only 6 instructions. And so my goal right now is to try to figure out how to get this again. And so here we go. So this works, but this number is like, this value sits here most of the time. Like almost half the time that this program is running, there's a value sitting here waiting to be shoved in. This wouldn't have to happen if this wasn't the cell doing the math, if we could like split up the work somehow. And so check this out. We're going to do something called parallelizing. So instead of trying to do all the math here, what I'm going to do is I'm going to move what I get from up here left. Then the next thing I'm going to do is move what I get from up here to the right. So you guys see what I'm doing now? So now I can do my math, let's say, here. And so let's move what we get from the left to the accumulator. Let's add the accumulator to it, so we double it. And then let's move the accumulator down. Alright, and then over here, let's move what we get from the right into the accumulator. Add the accumulator. Move the accumulator down. Now let's move what we get from up over here to the right. Let's move what we get from the left to the right. Whoops. Yep, sorry, I must have something bound to the arrow key that I didn't realize I had. Sorry about that. Alright, so now I'm going to notice that this node now has stuff coming from, this node here has stuff coming from both the left and above. So I could, in theory, write 2 instructions, but if I did, one of these numbers is just going to sit here waiting for the program to finish. So what I'm going to do instead is say move from any direction down. And then same here, move from any direction down. Okay, so that uses 7 nodes. Let's see what happens. Okay, so now 66 is moved over. Oh, that's no good, huh? What do you suppose happened? Seems like stuff's just waiting. It's weird, don't you think? So what do you think we did wrong? I'm going to guess that it's stuck in something like a race condition. That's actually not the right word, I'm sure. But like, watch. So 66 comes in. It moves over here. Oh, do you see it? I totally do. This is now waiting to take something from the left edge. But that's not the left edge, is it? So, I'm going to fix the stupid bug. now watch. Much faster. Still not my best, but much faster. 104 cycles. Also, you'll notice that 7 nodes is the rare case. So I'm on to something with my node usage, but maybe I'm not spreading around the math right. Maybe there's a more efficient way to do that. And so if I wanted to, I could just keep going and keep refining this and keep refining this. But I actually have a pretty good run. Turn to the segment list. So let me show you this program. And you can see this actually uses even fewer nodes. Much better code. So check this out. So when this one brings a number in, first thing it does is send it to the right. And the right will take anything, throw it in the accumulator, double it, and move it down. The node below it does the same thing. So this is kind of like the same design from before, but notice it uses a lot fewer nodes and a lot fewer instructions because I'm using this any command on these 2 nodes here and not going all the way around, just dumping it down and over. So really this is the same program, just more efficiently. Or more efficient, excuse me. Oh, hey Sale, how you doing? Right, so now you can see 84 cycles, which looks like it's the small case. 5 nodes, there's a way to do it in 4. I'm kind of curious about that. Or sorry, not 4, I mean 6. There's a way to do it in 6. I'm kind of curious about that. Alright, so that's that puzzle. And this one you can see I actually have been trying to work on a couple of times. This is the one I'm on right now, and this is a hard one. So what I need to do is I need to take in the value from A and the value from B. And then I need to subtract A from B and output it here. And I also need to subtract B from A and output it here. So, I'll show you how I did that in a second. So, from July 19th, 1979, it says, interesting. Looks like there's some kind of static memory in this thing. Encoded something or other. So now I think Randy's trying to figure out what's been stored on the device, and he's trying to unlock it so that he can actually see what's there. I'm curious because I suspect I might know what it's going to be. But one thing at a time. Alright, so the first thing I'm going to do is I'm going to say move anything I get up into the accumulator. And I'm going to do this on both of these input nodes. So what I'm going to try to do... Oops. That was nice of it. I've never seen the debugger before. So what I'm trying to do is I'm going to do the math on each with the value by using this backup registry. So, for example, I'm going to, now that I've got it there, I'm going to save it to memory. And that, like I said, will commit whatever's in the accumulator to this backup node. So now I have a way to do math without messing up the original values because I'm going to need them. Right? I should need them, shouldn't I? Well, wait a minute. I just need the opposite of each, don't I? Oh, wait. Maybe there's a math nerd way to do this. Huh. Okay. There is a command I saw in the manual that will let you negate a value. So if I'm not wrong about my math, then I can just do one of the 2 operations and then output the negative. Yeah, okay. So then I can go sub left. Okay. That does the subtraction. Alright, so then I can just move the accumulator down. Move that down again. Okay, so now I want to move it to the accumulator. Then I want to move the accumulator down so that I output the original value. Then I want to neg. You just can't do it. Right, I'm negging. You know what, never mind, that was stupid. Alright, so then I want to take the now negated accumulator, and I want to move it to the right. God, I can't tell right from left tonight. That's terrible. Down. Now, if I'm right about that, that should work. Oh, I did something stupid. I can't. God damn it, right from left. I'm still doing something stupid. Okay, there we go. Ooh, it's kind of slow. There's probably a more efficient way to do this then. Maybe distribute these commands out a little bit. Yeah, 240 cycles. Oh yeah, see, there's a much shorter answer. Damn. Damn, and yeah, you can see I actually got it down to 201 in my previous one. I have beaten Scutarius pretty soundly here, though. I am kind of proud of that. See, Scott's an actual, like, programmer. I'm not. Okay, so it looks like the most popular answer uses more nodes. So maybe I'm right about distributing that math. On the other hand, maybe the most popular answer is the obvious one, so maybe I'm wrong about that. It also looks like a higher instruction count is more popular. That I've found a pretty good. I've probably found the lowest instruction count solution. I am curious now. All right, well let's try messing with that. So why don't we send this down? Send this down. Why don't we send this down? Okay. I do have something bound to the up arrow. That's terrible. Sorry about that. Alright. So now we've got this going on here, right? What are we going to do with it? Let's move it to the accumulator. I've already got the other one set up, so let's move this left. Let's do the math here. Sub left. Whoops, sub right. God damn it. Okay. Still puts a lot of instructions here, though, doesn't it? I'm not actually sure that's better. Let's find out. Oh, that's no good. I've never seen that before. Oh, no. I'm not moving it to the accumulator first. Dumbass. This needs to be move the accumulator down. Does that fix it? There we go. That's a little zippier. Still pretty slow though. Oh, wait a minute. It's the exact same number of cycles as before, isn't it? God damn it. Yep, all that did was add an extra node that literally didn't help at all. Bah. So this is the fastest way I found to do it. Oh, I see. Yep. I did the original math, just the subtraction really quick, and then did everything else here. Clever. So here's this version. Number comes in. This one moves here while this one moves to the accumulator. Then I subtract the value of the left one. Move it down. It comes into here. Throw it into the accumulator. Then I move one copy of it down. Move the other copy left. There it gets negated. Then it moves down. And it comes out of the right output. And it goes like this. 203, 6, 12. See, I was a better coder last night than I am today, apparently. Alright, let's try a totally new, one. Okay, first I'm going to read the message because I want to know about the story. Let's see, September 3rd, 1979. Found a block of static memory, but it's in a proprietary format I never saw before. Can't make heads or tails of it. Oh, brother. There's just too many different kinds of machines coming out now, and I like tinkering with them as much as the next guy, but when every Tom, Dick, and Mary implements their own memory address scheme, it's all... I say the bottom's going to drop out of the microcomputer market soon. Mark my words. Yeah, totally, dude. Randy was on it. Surfing the edge. Alright, so what the hell am I doing here? I need to read a value in. Write 1 to out G if that value is greater than 0. Write 1 to out E if that value is equal to 0. Write 1 to out E if that value is less than 0. When A is 1 is not written to an output, write A equals 0 instead. Oh, okay. Okay. So now I'm doing conditional checks, if-then branches. Let me see what those commands are. Don't forget, this is assembler, so you can't do complex stuff like that in the same way. You're going to have to use something called a jump, JMP, where you jump to a label. Let's see. Okay. So we have standard JMP, which just jumps you to a label. We also have JEZ, which jumps to a label next if the value is 0. Then we have JNZ. Oh, I see. J equals 0. So jump equals 0. JNZ is jump negative 0 is below 0. Oh, is not 0. Sorry, jump not 0. My bad. Then there's JGG, JGZ, jump greater than 0. Or JLZ, jump less than 0. Okay. So... we want to do out G if it's greater than 0. So we want to go jump greater than 0. Wait, first we want to move anything that's coming in from the left to the accumulator, because all of these are tests against the accumulator. Oh yeah, look at me being fancy. Sigh. Alright, there we go. Now we want to say jump greater than 0. Do it. Yeah, I know. Don't worry. I'm doing this right. I'll come in a second. So now we go do it. Yep, see? Perfect. Now remember, we're supposed to let's see, we're supposed to write a 0, which is the default value of the ACC. Okay. So first we need to sub ACC to make it 0. Then we need to move ACC down. Wait a minute. No, we don't want to move ACC down. We want to move 0 down. I don't need to do any of that. I'm being stupid. There we go. Otherwise, we want to move the ACC to the right. Now this one, to write out a 1 if... Oh, wait, that's totally wrong. God, my logic is terrible. Look at that. Alright, so we move a 0 down, and we move the ACC to the right so it can continue its test. Then we want to move a 1 down. That's better. Sorry. Okay. So here we want to take whatever we get in from the left into the ACC. Then we want to do jump equals 0. We'll say count 0. That's a William Gibson joke. Alright, let's see. So, if it's not equal to 0, then we want to move 0 down. We want to move ACC to the right. But if it is equal to 0, then we want to move 1 down. Finally, we'll take what's from the left into the ACC. This is jump less than 0. Oh, wait a minute. If we're here... Yeah, if we're here, then we don't have to do any of that. Just move 1 down. Because less than 0, right? So now I just need to shuttle the data down. Wait a minute. There we go. Alright, I think that's going to work. Famous programmer last words, by the way. Yep. See? That's not working. Oh! I know why it's not working. This is not the right place to do that. Okay. So this stuff's executing immediately. Yeah, it's this one, isn't it? Yep, it's this one. So I still got to label that. And I still got to move data. Okay. My bad. Still think I can do that, though. There's got to be a way to make it just wait until I tell it to. I wonder if I can do, like... And then be like... instead of any of this stuff, just go like... jump answer. See if that'll work. Oh, hey, Bounce. No, why is that label undefined? No good. No joy. Maybe I don't understand how jump works. Oh, their labels have to be within the same node, so that's not the answer either. Okay. Hey man, Bobby Wilson was a genius. Or Newmark, I mean, Bobby Newmark. Feels like such a waste of a code instruction. Looks like it's working now, though. I spoke too soon. Alright, well, how did it break down? Wait, I'm totally confused now. Sorry, I'm gonna have to start over. I didn't see that happen. Alright, so 2 comes in. That worked. Okay, so the next number is 1. That comes in. It's not equal, so it moves on. Or it's greater than and it goes down. Sorry, my bad. Alright, 2 comes in. So this node clearly works. 0 comes in. Moves a 0 down. Then it moves the ACC value over, which is 0. Now 0 comes into this node. Checks to see if it's equal to 0. Moves the 1 down. Wait, how did they get out of sync like that? Oh. Oh, you're totally right, Sale. Man, I wish I'd looked up there earlier. Son of a bitch. Bet you that fixes it. No. So it didn't work on the -2 case. On the second -2 case. No, it didn't work on the first one. Why not? Hmm. Fuck. I see why not. It's right there. Do you see it? I forgot. These labels aren't exclusive. So what I need to do is I need to jump around this stuff. Hmm. Oh wait, I think I can just actually, I may not need end. I was going to use a no-op and just jump it to a dead instruction. But I think I can just jump back to start. See if that works. It's been so long since I've had to do this. The last time I was actually programming in real assembler code, I was making a crack for the Laura Bow mysteries. I hate that that button is bound. Sorry again. So, yeah, I was making a crack for the Laura Bow mysteries, a series of adventure games from Sierra at the time. And the only way to get around their copy protection was to debug their code in real time and then jump around it. And so you had to learn assembler because the debugger would disassemble the machine, or would assemble the machine code into assembler for you to look at. Exactly, Oboa. No need for the no-op. I know exactly where to land. That's funny, man. Alright, let's see if this works. I think it will, though. I'm pretty sure that'll do it. Alright, the 2 makes it. The 1 makes it. The 2 makes it. The 0 goes across. Or, I mean, the accumulator goes across, yep. It jumps back to start. Moves the -2 in. Crap. Wait. But shouldn't that output a 1? Oh, do I have my nodes in the wrong order? That'd be embarrassing. No, write 1 to out E if it's equal to 0. What did I miss? Oh, stop. Damn it. I wanted to step through, not run. Okay, I need to follow this 0 through. Okay, the 0 comes in. It's not greater than 0. So we send a 0 down. Move the 0 that we got as input over. And we check to see if it's equal to 0. It is. So we move a 1 out. Why is... Oh, son of a bitch. I see what's wrong. I need to pass the number on even when it's right. So I was actually doing it super efficiently, but it turns out that actually wasn't the answer that they wanted. So I was cutting out the operation of the out E and out L nodes when out G had the answer, and vice versa for all of them, right? But they wanted to know that each of the other nodes failed, and I'd forgotten that. And so I wasn't moving the value over so that the right thing could get moved over, even though I had written all the code to check for it. It was kind of stupid. I think that'll fix it. Okay, so the 0 is still not working, but the less than is. Alright, what's wrong here? So you move what's on the left to the accumulator. Okay, what's going on? I already see a way to make this faster too. Damn it, I wish this bug wasn't here so I could score better. Alright, so the 2 makes it out. Gets sent over. 2 is not equal to 0. Oh, I see what's wrong now. There is no command to move the 0 down. God damn it. Okay. Have these commands here twice. I shouldn't do that. I should do this. And then I should jump to end. if I do that, I don't need start. And that's because this command was being done by both of them anyway. And in theory, that should work. Yeah, I figured it out, Bounce. It took me a little while. I didn't realize. I just lost track of the. I just lost track of the goals of the damn level. All right, let's try this. All right, it's a little slow, but it looks like it's finally working. Much better. Much, much, much better. There we go. Okay. Oh, look, I got one fewer instruction than Mr. Bounds. All right, so I think I'm probably going to call it a night. That was TIS-100. And I suppose if you don't like programming, that was probably the most boring stream I've ever done. But if, like me, you find stuff like this pretty cool, you should totally check out the game because it's totally worth it. I think that's it, though. I'll be back this weekend. Definitely going to do something head-to-head with Ombois. We may try to get other members of the DOP crew involved. So check us out. We'll be on Twitch and YouTube tonight. Probably in about 7 minutes, maybe a little bit more, Mr. Ombois is going to be hunted. He's going to play Sir or Madam, You Are Being Hunted, so check it out. Until then, see you guys later.